to ask them while we are doing the course. The reason is in earlier days where I was able to come to you and check what happened to your code and do things like that. There will be some coding part involved, but in this format, it will be very hard for me to know if there are any problems in your code unless you tell me. Okay? So we will be writing some code. So if you have any issues, please let us know. By the way, we used to use MATLAB for this particular course, but unfortunately, I forgot to inform you about that requirement because other days we usually work at the laboratory. So in the lab, you already have the MATLAB installed. So please let me know how many of you have MATLAB installed. Are there any person who doesn't have the MATLAB installed? If you don't have the MATLAB, we can find some alternatives. Because for the today's session, we can use either MATLAB or the Octave. But from later days, from probably the next week onwards, there will be some specific tools we will be using, and MATLAB is the best way to do them. But for today's basic programming part, it's not a must to have the MATLAB. If you don't have the MATLAB, I can send you a link for an online Octave version. So those who have MATLAB, can you press the yes button in the window, in the chat window somewhere? Chat windows, in the participation window, you will see the yes button. Okay, 2 people have pressed it. So if you have it, press it so I can know how many of you have MATLAB. And if you don't have the MATLAB, press the no button. Okay, 3 people have it, 1 person don't have it. Okay. Okay. It seems like we have about 50-50. Right. Here's what I'm going to do now. Then we will be doing a set of codes that will be compatible with the Octave. So that means the same code can be run in both MATLAB and Octave. And the Octave have a free online version. So MATLAB, Octave have free online version. So we can use that particular version to test the code. So at the beginning, I will show you how you can work on both. But after some time, I will only write the code either in Octave or in the MATLAB, whatever that seems easy. And you can run the same code on the Octave or the MATLAB without any issues. But from the next day onward, try to find a MATLAB version. If you want, I can ask Mr. Amal or someone to see if you have if you can download this version. If you can get something 2013 or newer, it would be good. Okay. Yes, I am recording the session. I will try to upload it when I have the time. So now I am sending you a link. If you have the MATLAB, you can have it, keep it open, or you can start it. If you don't have the MATLAB, go to this particular link and it will open an online session. And you may need to use your email to log into session. Even without the login in, you will be able to write the code, but you will not be able to save the code. It's better to have the chance to save the code. So if you don't have it, try to create an account. If you have a Gmail, you don't need to create an account. You can just log in and find a link like that. So if you log into that window, you will see something like this one. So this is the Octave window. And later on today, we will be using that one. But for the time being, we don't need it. But somewhere after about half an hour, we will start coding. Okay, now let's move to the main topic. So in this course, we will be talking about artificial neural network. So the ANN shortly stands for artificial neural network. So let's start by a simple question. Here's a question. Name few areas where computers are used. For example, in the banking industry, computers are used to calculate things like interest rates and calculate different kind of payments. Those things are calculated using computers. What other areas do you know where computers are commonly used? What other areas are computers commonly used? So this is a Zoom session, not a lecture, not a recorded lecture. So you have to answer. It's going to be interactive one. Otherwise, you will fall asleep. Even in the days, even in the normal lectures, some of you fall asleep. R&D, okay, that's a wide area. R&D, okay. Anything you see in everyday life? I don't know. There are so many places you can use computers. Now, when you say computers, it doesn't have to be a supercomputer or a desktop or something. Some computers are very small. Yes, in broadcasting area. Audio and video editing. Okay, medical instruments. Okay, here's the second question. What areas of computers are not involved so far? For example, I know computers are not good at cooking food. Right? So far, I don't know any computer that is capable of creating a menu and cooking. So what areas where computers are not used that much? Now that should be an easy one. Because you don't know much about areas where computers are used, you should know about areas that computers are not used. If you want, you can unmute and say your answer. Okay. So if you look at decision making in public matters, okay. Yes, that and maybe politics, which is related to your one. Medical surgeries, yes, surgeries, it's not that used. So you can see there are two areas. In one area, computers are commonly used. Saloons, artistic, yes. In other area, computers are not used that much. At least we don't see it at the modern time. So why is this different? What makes certain areas suitable for computers and certain areas more suitable for humans? For example, if you look at my example, accounting, managing accounts. Now it's very hard for a person or accountant to do everything manually. But a computer can do it very easily. It can store all the values and do the calculation precisely and do it. But on the other hand, if you look at a case like drawing an art, maybe writing a novel, it seems humans are able to do it much better than the computers. So why is that? Why are there two different places, two different categories? What might be the reason? Or if you look at the medical surgeries, huh? Any idea? And the reason has to do with certain rules and limitations that imposed on their behavior. For example, if you look at the data and information, sometimes these data can be very precise, sometimes they can be noisy, and sometimes imperfect or missing. For example, if you look at the banking industry or any other area that use a computer, they have a very precise set of information. If a computer is playing a game of chess, it knows where each piece precisely. If it is doing a calculation, it knows the values precisely. However, sometimes things get noisy. For example, if you're thinking about medical surgery, you might have a theoretical idea where this particular tumor or something should be, but when you actually cut the patient, the things might not be like that. You might not be able to see the things. There might be some deviations from the originals, things like that. And sometimes data is also completely missing. For example, let's say you want to predict whether tomorrow is going to rain. But unfortunately, you may not have all the data. You may know the temperature and humidity, but you may not know other things like the wind speed and what's happening at the other side of the continent. Those things may not be there. So some of the data might be missing. And sometimes the sensors can produce noisy and imperfect data. Right? Same thing applies to rules and instructions. Right? Sometimes you know exactly what to do. You know the formula to get the result. But sometimes you have no idea what to do. Right? It's just like in the life. In the life, sometimes you know exactly what to do. Sometimes you have no idea what to do. Right? Some rules are missing. Sometimes you only know partial facts or partial rules. You know if this happens, that can happen. But other than that, you don't know anything. The last factor is how complex your computation can be. Right? Now, as humans, we had been so used to doing automated kind of thing, we don't see the complexity in our everyday motions or everyday things we do, right? But if you look carefully to analyze each of them, you will realize some of these things we do involuntarily are quite complicated. For example, think about driving. Now, if you are driving on a rainy day on a road, you have so many things to think about. You have to be conscious about the road condition, and you have to know about the people who are moving here and there, and you have to think about the vehicle that is going in front of you, and if there's a three-wheeler or a bike, whether he's going to overtake in the wrong side, and due to the rain, maybe your vision is completely blurred. Because every time a train drop hits your windshield, the field, the thing you shield, the thing you see get distorted, right? Because it's basic optics. So then you have to correct it. And if there's a viper moving in front of you, you have to ignore the viper. Right? You should not think viper as something moving across the road. Right? But most of these things happen automatically in our brain. So we do not see the complexity in these things. But if you ever try to do it using a computer, then you get to idea how complicated these actions actually are. That's why even now we don't have many automated cars in the world. There are a few, but they do have very high number of limitations and constraints. Right? But for any average human, that would be a very easy task to drive a vehicle. So there are certain facts like that. So in basically, you can see there are two types of categories. Sometimes you have data and information very precise, rules are well known, and computation complexity is very low. Those areas you can apply computers. But in everyday life, most of the scenarios will be the other way around. You will have some of noisy data, you will have some data missing, and you might not know exact rules. So those things will prevent a computer being used in those areas. Have you got the idea about what I have taught you so far? Some basic background. Now you have to start giving me feedback. Otherwise you have to say yes or no, or put some comments. Okay. At least one person start commenting. Anyone else? Okay, good. So the computers that you have seen so far in common are programmed in a certain way. They are known as hard programming. But in the modern day, you have a different category of programming evolving. Sometimes they are known as AI, but what I'm mostly uh, focusing on is a subcategory of AI known as soft computing. Now, in the soft computing, computers try to think like people, and they are able to handle imprecise and uncertain partial data and truths. Right? So they are more and more like the humans. Sometimes we don't need the full data to get to a conclusion, and computers are trying to be something like that. And the same as the humans, the answers you get may not be 100% mathematically accurate. Because if you don't have enough data and enough information, you can't expect a 100% accurate result. But they should be enough to get going. So that's the target of the soft computing. Now there are so many areas in soft computing. Neural networks is just one. Okay? So even today in the modern world, neural networks have become a very popular one, especially the deep neural networks, convolutional networks, and things like that. Other than that, you have things like fuzzy logic, genetic algorithms, Bayesian networks, and so many other things. Okay? But in this course, our focus will be on the artificial neural networks. So for the short, from time this word, I will just call them as ANN or neural networks. But what I actually mean is the artificial neural networks, right? So here are some of the common areas where the neural networks are used. They are used in classification, clustering, prediction, and associative memory. Now, classification means you know there are a certain number of groups and you want to put an item into one of these groups. Let's say an OCR. Now, OCR means you have a handwritten document you want to convert into a standard text. So now the computer knows if it's in English, there are a certain number of letters and punctuations in the grammar. So it will try to classify each of your symbols into them. Clustering is the grouping, but without knowing the number or the actual rule of grouping. For example, you might have a collection of marbles or stamps or something. You want to group them into several groups, but you don't want to exactly say whether you want to group it by the size or the shape or something. You just want to find a similarity. So the computer might decide to group them by size or the shape or the color, or maybe a combination of all of them. Predictions are quite common. They can vary from predicting the share market to predicting the rainfall. Right? So that's another area. So it's the associative memory. So with that, we will conclude the basic introduction and try to move into the actual neural network course and to build some neural networks. But before we start doing that neural network building, you need to have some very basic understanding about MATLAB or actually programming. So I believe you have already covered a little bit of MATLAB in the earlier semester. Have you covered MATLAB earlier? I think you should. Have you done MATLAB course in the previous semester? Yes, you have. Okay. So I will try to do it a little bit faster. I don't want to cover everything from the scratch. So if you find anything a little bit too fast or complicated, feel free to stop and ask from me. I think you're familiar with this one. This is the MATLAB window. And whenever you want to write a new program, you just go there and click new script and you get it. And here you have the current folder, and the workspace will include all the variables you had created. So you will be writing your code in here. And you can see the results in the command window. Right now, there are several variables that are there I had earlier used. So I can clear them using the CLC command. So it's good to use the CLC and clear all. Now clear all command is the one to clean the workspace. Clear all command at the beginning of your every script. So that goes for both MATLAB and the Octave. So it will help you have a clear workspace and start the programming. And you need to save them as .m files. And before you run the program, you need to save each of them. And once you've done this one, you can run the program using this run button. For example, a very simple program, x equals 1, you run it, and you can see the answer in the command window below. Answer in the command window below, and same time you can see the variable here. So that's in the MATLAB. Now you have a similar thing in the Octave. So I'm using the online version because I don't know if you have enough time to install it. But there's an offline version as well. In fact, offline version is the most popular one. So I hope you had gone to this particular link. Now, students, you don't need to do the board, okay? You have to choose one. For today, I think it's better to choose the MATLAB, but I learned there are several students who are not having the MATLAB installed. So this Octave one is for them, okay? So this is the Octave. Let me put it the full screen anyway. So the Octave, this is the editor, so you can write your files or anything in here. In the MATLAB, you don't need to save it when you are running the program. It will automatically save and run the program. But in the Octave, you have to first save it using the save button and then run the program. So this will be the command window, and you will see the details here. And this would be like the workspace. The column in the middle would be like the workspace. And you will be able to see the variables here. There's a question. What is the difference between AI and the ANN? Now, AI is a very broad area that stands for artificial intelligence. So neural network is just a small component in that area. When people are trying to build the AI, that means computers that can think, and they are using different technologies or different things. They are trying different things to do that. And ANN is one of these things. But AI is a much broader area. It has many other categories other than ANN. Okay, coming back to the topic, here you have the workspace, and this is the place where you see everything. And in the menu, you can make change the theme and things like that. So close the menu. And if you want to have a new script, you can click on this one. Let's name it new script. Another difference is in the Octave Online, you have to put the .m file extension in your file. Otherwise, it will not work. In the MATLAB, it is not needed. We have the new script. And now I'm going to okay. So this is the new script, and I'm going to edit this one and say x is equal to 5, just like I did in the MATLAB one. Save it. Okay, I might need to refresh this window. Please give me a second. Okay. New script, my script.m. Okay. Instead of this, I will say x is equal to 1. Save it and run it, and you can see the result appearing at the bottom of this one. X is equal to 1. And just like in the MATLAB, you can see the variable here. If we click it, you can see the same thing. Okay. So I think now we have got the idea of the two different softwares. So we can run the same code. Only thing is in the MATLAB, you will be writing in the editor, just like a notepad. If you're using Octave, you will be writing codes here. In the MATLAB, to get a new file, you have to go to the file menu and click the new script. In Octave, you have to go there and click the file, click this create new file icon and enter the name here. In MATLAB, you can directly run your program, but in Octave, you have to first save the file and then run the program. If you want to go to an old file, in the MATLAB, in the editor, you have different tabs, but in Octave, you have tabs on the left side. So those are the main details, main differences you will find when doing the programming. Other than that, I think it's almost the same. So it should be okay for you to use either of them. So we'll start with some simple things. Let me shift to MATLAB. So in MATLAB, your files are saved in below. In the tabs, you can see the files. In Octave, it was in the left side. Right. First thing is to remember is you need to put comments in most of the time, and comments are started by percentage sign. And in MATLAB, variables are case sensitive. So the capital X and simple X are two different things. And don't ever save a file with starting with a number or space in between. Then your program will not work. So no spaces and do not start with a number. So that goes for both file names and the variable names. And don't use keywords for the file names. Right. Let's start with a very simple situation. How do you start a variable? Now you already have seen it, X, a sign, and some number, and you will get this one. So this is the easiest way to create a variable. What about creating a one-dimensional matrix? So if you want to create a one-dimensional matrix, put square brackets and start typing the elements 10, 20, 50. You run it and you get something like this. If you double click on this X variable, you can see the values as well. Okay. Now you can do the same in the Octave. So I'll just replace it with this code. I copy paste. Save the file and run it. And you can see the result. The same result, but shift it a little bit. Okay, you can see X 10, 20, 50, and you can see the variable X here. If you click it, you get a pop-up with the variable values. Are you okay with it? How many people are using Octave at the moment? Okay. One person is using Octave. Anyone else? Okay, offline, that's fine. People seem to be shifted to Octave. Okay, fine. Right, then I will try to balance both of these cases simultaneously. So now you know how to create one-dimensional matrices. What about if I want to have a two-dimensional matrix? Now, if I want to have a two-dimensional matrix, the same as the previous case, Only difference is between the same, within the same row, you just use commas or spaces, but at the end of the row, you put a semicolon. Okay. So up to the first semicolon, you have one row, and after the semicolon, you have another row. If I want, I can put another semicolon and type the another third row as well. So when I run this program, you can see it's a two-dimensional matrix where you have 10, 15, and 12 in one row, and 50, 25, 22, and 23 in the other row. So that's how you create one-dimensional or two-dimensional matrices in MATLAB and Octave. Okay, so it is very important you get familiar with these things, because after doing this, we will be directly jumping into the neural network. There, I will not have time to explain MATLAB syntax. So if I ask you to run this 100 times and check if x is larger than 10, you should know how to do it. Okay. So this is one-dimensional, two-dimensional matrices. Let's say you can do a simple matrix addition or something. Okay, we'll do a transpose. Transpose means you're basically interchanging rows and columns. So if I do this one, Y transpose, you can see this first row had become the first column, second row had become the second column. That is the transpose. It is very important. Syntax. During the programming, you will have many times where you need to transpose a matrix. Right. How about matrix addition? Now, I'm not going to much details of the mathematics. You should know that matrices should have the rectangular shape, and there are certain restrictions on how to do the addition and multiplication. So I'm not going to that details because those are not part of the syllabus. For example, when you're doing a matrix addition, the size or the dimension of the both matrices should be same. So if I do this particular one, you can see I'm basically adding X and A. But if I don't want to print all these earlier results, I can put a semicolon. So they will be stop printing. Only my last line will be printed. Okay. Are you okay up to this point? Any questions you want to ask? Good. So next time when I'm asking you to create a matrix, you should be able to do it. Okay. And by the way, people who are using the Octave, you can share your workspace with me. Right? You can send me a message in the chat window as private or something. Then I can click and check your code. Unfortunately, for the MATLAB, if you want to use the sharing function, you have to pay some money. Right. Now let's try to do a matrix multiplication. Let's say Z is equal to X times A. What do you think is going to happen now? You can remove these two, I don't need it. What is going to happen if I type this one? Will it work? Why not? If it's not going to work, why not? Yes. If you want to do a matrix multiplication, the sizes should be compatible. So if I try to multiply this one, you get error like this. So I can't multiply a 1 by 3 matrix by a 3 by 1 matrix. Sorry, a 1 by 3 matrix by a 1 by 3 matrix. So this one, if I transpose, I can get a result. Or if I want an element-wise multiplication, I can use the dot or the vector operator. So what do you mean by dot operator? So then the MATLAB will ignore these two as matrices and consider them only as separate elements in a vector. So the first element of the matrix A will be multiplied by the first element of the matrix B, and the first element of matrix A will be multiplied by the first element of the matrix X will be multiplied by the first element of matrix A. Second element of the X will be multiplied by the second element of A. Third by the third. So you can see, you get 10 into 15, 150, 20 into 24, 480, 15 into 81, I get 12,250. So if I want to get what I get from the transpose, I can simply do a summation and I get the result. Are you okay up to this point? So for the Octave people, let's try to do that one. So you can see you get the same result. Yeah. Now let's try to use another functionality available. If I want to have a set of numbers, there's an easier way to do it. If I say something like, say, 1 to 10, you can automatically generate a set of numbers starting from 1 and ending at 10. That is another thing that we can use in our neural network to make it a little bit easy to do the program. Okay. So are you okay up to this point? So you need to know the basics of creating one-dimensional, two-dimensional matrices and matrix operations. Matrix operations means addition, subtraction, and multiplication, and transpose. Other than that, you need to know some basics in MATLAB, like doing normal additions and printing results and things like that. Are you okay up to this point? So you know how to create a two-dimensional matrix and do multiplication, things like that, right? And you also need to know about this vector multiplication or the dot product. So the dot product means you are multiplying one element by the relevant element of the other matrix. So it's not multiplied as a matrix multiplication, it's done as a vector multiplication. So are you okay with this one? Are you up to this point? Okay. Then we are going to learn another common syntax, the if condition. So how do you write if condition in MATLAB or Octave? Can you type in the chat window? What is the syntax for if condition? You're partially correct, but in MATLAB we don't use curly brackets. Curly brackets are usually used in C or C++ or Java. MATLAB we don't have curly brackets. There are places, but not in the if condition. Instead, there is a different way to terminate the if condition, or to denote where the if condition ends. If you have done the MATLAB, then you should know. So can you type, someone else also type? Because in the final exam, you might have to write the programs. Not might, you would have to write the programs. So you would need to know the basics. At that time, there will be not enough sufficient time to do the actual learning. Okay. So the condition goes like this. Let's say I want to check whether X is, let's get another variable. C is 10. If C is larger than 5. So this is the case, condition. And then what do you need to do? You can say R is 1. Then you end it with the end command. If followed by the condition, then whatever needs to happen after that, and the end. So if you run it, you will get R as 1. If this is less than 10, you don't get anything. After C, you don't see the R. What will happen if I need to set R to 0 if C is larger, C is smaller than 5? Then what should I use? If C is larger than 5, I need to set R to 1. If C is less than 5, I need to set R to 0. How can I do that? There's another modification for the if condition. Yes, we can use the else command. Else R is equal to 0. Now this is our little program. So when you run it, if C is 10, you get a certain value. If C is 0, you get a different value. So I hope you are okay with the if condition. It's very straightforward. You should also know how to use logical operators. That means AND operator and O operator inside the condition. You can use the disp command to display any value. For example, if I run this one, you can see the result, some other number. So that's basically displaying the content in this point. Let's move to the next common syntax. It is the for loop. So what is the syntax for the for loop? Can someone write it? Syntax for the for loop. What about the for loop? Can you write the basic syntax for a for loop? Yeah, that's correct. You can basically write for I equals 1 to 10. Let's print I. Uh, so if it's a while loop, you can put the condition. If it's a for loop, you just set the iteration number. Okay? So when you run this one, you get values printed from 1 to 9. And you can do anything inside it. Okay, so there are 10 hellos printed here. Okay. Here's a simple question. We have two matrices, A and B. A is, let's say B is 5, you don't have equivalent matrix. A has these numbers and B has these numbers. You have to first multiply A by 5, multiply A by B. Okay. Then for each element, if it is larger than let's say 12, display large. Otherwise, you have to display small. So you have to print two words depending on the value of the each element. Did you got the question? There are two matrices A and B. Multiply A by B, and for each element you have to print whether it is larger than 5 or smaller than 5. Can you quickly do it and share the result either in the chat window or maybe if you're using Octave, you can share it directly in the Octave. If you're using the Octave, in the menu, there will be an option saying this one. So using this one, you can share your code and the result and everything. Anyone finished? Okay, we'll run this particular answer and see. So this answer has a small issue because you need to, you can see the X actually has 5 elements. So for each of these elements can either be small or large. So you have to go through each element and then decide whether it's larger than 12 or not. So you need to have a way to iterate through each of the elements in the X. So see if you can modify that part as well. It's almost there, except you are missing that iteration or looping part. Okay, the second code is I think almost there, except for one small issue. If you run this code, you will find there will be a small problem. Okay, for some reason it seems to be working, but I think there might be some problem with the code, because when you're addressing an array, you should use the parentheses, not the square brackets. The square brackets are used when you need to, usually you need to create a matrix. Okay, I think I can see the same result happening here. So if you look at this one, the first element is actually 1 multiplied 5 is 5, right? So it should not be larger than 12. But in this code, everything is larger than 12, right? The reason is, if you want to address an element, you have to use the parentheses, not the square brackets. The other problem is, MATLAB uses one-based index system. Now, in the programming language, you have zero-based index system and one-based index system. That means, how are you going to start the matrix, an array counting? Are you going to start saying 0, 1, 2, 3, or are you going to start 1, 2, 3, 4? MATLAB is one-based counting method. So, if you can't access M0, the first element would be M1. Right? So, there are two things to correct. Somehow they had come together and make your code looks a little bit okay, but you still doesn't get the correct answer. So, this one should actually be parenthesis times I. So this will take the ith element in the M matrix. That part is correct, but now you get a different error. The error says subscript indices must be either be real, positive, integers, or logical. So it should be real positive. Now 0 is not a positive number. So you should start with 1. But once you put a 1 here, you will get another error. Ah, that's okay. You have taken the length of M, right? You didn't type the number as 5 or 6, you have to use the length. The length is 5. So 1 to 5. Okay, now your code is working. Okay. So there are some small things that you need to work out. What about other people? Okay, that code seems okay. So Gayani, your code seems okay. Lakmal, your one seems to be okay too. If you run these codes and if you get the expected answer, then there's nothing to worry about. Okay, now you can see smaller than 12 and larger than 12 correctly appearing. So just to make sure, let's put the Lakmal's code and see. Okay, it seems to be working. Anyone else want to send the code so we can check it? Right. Now that will conclude our MATLAB introduction session. Right? So it's a very brief one, and in fact, if you go to the LMS, you will find a much more detailed PowerPoint presentation where you can recap most of the things, so you can remember what you had learned in the last year. But for this one, I only covered the things that are essential for our neural network course. Other things I have omitted. Now, shall we move to our main session, where we will be discussing about the actual neural networks. Do you have any questions? Anyone have any questions? Attempt to reference field non-structured array. What happened here? We have got the answer from it. Right, now we know the usage of neural network and we know they are used in soft computing. In other words, they are used in the fields where the data can be imprecise and instructions are well unknown, or the computing complexity is too large. Right? So what is a neural network? Now, one definition you can understand is this one. So neural network is a collection of simple processors connected together to perform processing and representing data as a group. So neural network is not a single processor or a single mechanism. It's a collection of smaller processors. And together they can process information. So it's like the human brain. Now, if you take a single cell in our brain, it is not a very, doesn't look very impressive. It's a very simple thing that can do a very simple task. But when you have millions of them connected together, then it becomes a much more powerful thing. So the connections together and working as a group make it more powerful. It's similar with the neural networks. You can't take a single neuron and ask it to do something complicated. It will not be able to do it. You have to make it a full network. And just like in the brain, you can't pinpoint a neuron and say, this is the place the decision has taken. You can't pinpoint a cell and say, okay, this is the place where you have to remember the last year's lecture. It's not like that. It's as a group that has the thing together. So it's a good thing and bad thing for the neural network. The good thing is it makes the programming or the teaching process much easier. The bad thing is neural network is more or less like a black box. We don't know how we get the results. You may train a neural network and you may get good result, but it is unable to explain how it got the result. Okay. So what you should know from here is a neural network is basically a collection of smaller processors that are connected together, and they function as a group. So depending on how these neurons are connected, these networks have different names. They are categorized based on the connection type. You have feed-forward, recurrent, radial bias, and many other forms. In our course, we will be only focusing on the feed-forward network architecture. Feed-forward network architecture. For example, if you have a recurrent network, you will have a different way of connecting the neurons. Radial bias will have a different way. Hoffman network will have a different way. But for a feed-forward network, this is the way it is designed. You have a set of input elements where you give the data, and you have a set of places where you can get the result. In between, you have neurons. So what you see in circles are the neurons. Now the neurons are ordered in layers. So this is one layer, this is another layer, and this is another layer. Now within the layer, there are no connections. For example, this first neuron in the first layer is not connected to any other neuron in the first layer. But first neuron in the first layer is connected to all the other neurons in the second layer. Similarly, second neuron is connected to all the neurons in the third layer. You can see inside the single layer, there are no interconnections, but between the layers, you have so many connections. So there are different ways of naming the layers. Some people call this as the input layer and this as the output layer, and anything in between as the hidden layers. Some textbooks will have all these layers as hidden layers. Right? So I prefer this as hidden layers. So this is the structure of a feed-forward network. It consists of different layers of neurons. Each layer has multiple neurons, and inside the layer you don't have any connections. But between the layers, you have fully connections. Okay? Are you clear about what a feed-forward network looks like? Okay, then let's move to the next one. Now, I told you these are made from neurons. So what is a neuron? A neuron is a simple processor that we have talked about. So it can have multiple inputs, but it can have only a single output. It can have one or more inputs, but only one output. And inside this neuron, or attached to each of these inputs, you have something called a weight. Now, weight is basically a number. It's a real number. It can be positive or negative or fractional value. It's a real number. And inputs to the neurons is again numbers. Again, real numbers. A neural network can't work with other type of data. It can only work with numbers. And after that, you have a sigma function and a transfer function and the output. So how does a neuron work? It takes a given input, multiplied by the weight, and does it for all the inputs, and add all the results together. So input multiplied by the weight, to it, it adds this input multiplied by the weight, and add this input multiplied by the weight. It does it do that. So then you have summation of all these results. So what's going to happen next is it will be passed down to a special function known as the transfer function. So there are different types of transfer functions like hard limit, pure linear, and things like that. So transfer function will look at the input and do its transformation and send the output. So this output will become the input for the neuron in the next layer. That is the basic structure of the neuron. Right. Can you calculate the sigma value? It's known as the net value. In here, can you calculate the value at here for this given neuron? Here's a neuron. Can you calculate the net value? This means the sigma value for this neuron. There is a minus sign. How did someone get 2.5? Okay. You will get 0.5.
So,
yeah.
So what is the mean by 1, 1 and minus 0.5 to 1, like this relation?
You mean these numbers?
Yes.
Okay. The numbers I put in these things are the inputs. So a neuron takes a number, process it, and give output another number. So these are the inputs. So the numbers here are the inputs to the neuron. And the numbers here are called the weights. It's just a name. So the first layer, the inputs will come from whatever you feed into it, maybe OCR, a scanner, maybe some other audio device or something. Whatever you feed into it, that will be the input for the first layer. But from the second layer onwards, inputs will be the output from the previous layers. So numbers can be values coming from other neurons, or it can be coming from directly from the input layer. And weights basically mean a set of numbers that are attached to each of the neurons. So basically they are the connection strength. So that's structure of the neuron. So these are just weights I have put there. So you have one as the input, and attached to that input, you have a weight of 1. Okay, now after that, you have the transfer function. Now there are several types of transfer functions. The one that I'm going to explain to you is known as the hard limit. Hard limit means it's basically going to compare the input against a constant. If the input is larger than the constant, output will be 1. If the input is smaller than the constant, output will be 0. Okay, this constant is known as the threshold value. So that value can change. For this neuron, I had selected the threshold value as 0. Okay, so 0.5 is larger than 0, so output is 1. So if you have another neuron attached to this one will become the input of that particular neuron. Okay. Did you get the idea how this neuron works or how the calculation is done? The training and everything I will explain later. Did you get the idea how the calculation is done? For example, if I give you a set of inputs and weights and threshold, are you able to calculate the output? I hope you can do the calculation. People at the chat, can you hear me? Okay, then we shall move to the next part, not the next part, continuation of this one, which is where we try to implement a simple program. Right? So far we have calculated the output manually. So now we will try to do it using a computer program. Okay. So I will use the clear and C. Then I will call something called input. And this would be the set of inputs I will be giving for the neuron. So what are the values I have? I have 1, 0.5. So nice one, negative 0.5 plus 0.5, 0. So these would be the inputs. Then I will call W as the weight. You need to type them. And I will call threshold 0. Right. So I have started typing the code. So can you fill the rest of the code? So it will do what you had done manually. It should take the inputs, multiply it by the weights, and it should calculate the net value. Net means the sigma. It should calculate the sigma value. Then it should calculate the output. We'll call this as the network output or neuron output. Can you write the code for this one? There are some codes missing. Sorry, I thought I changed it. Okay, now I think you can see the MATLAB. So we started Play and CLC. So I'm basically using the MATLAB to do the calculation the neuron has done. I had put the inputs. Weights I hadn't put, you have to put the values there. Threshold I have put as 0 because that's the value I use. Then you have to fill in this particular gap. How do you calculate the net value? And how do you calculate the neuron output? Now, once you know the net value, you can use the hard limit or something to calculate this neuron output. You can put some intermediate lines if you want. What I basically want is to get the correct neuron output for a given input. Can you write the rest of the code and upload it? Okay, someone has switched to dance here, so you'll see input. Okay. Uh, okay, there's a code from the Lahman. I think it should work. So let's try to give it a try. First, you have the inputs in the vector and weights W again in the vector. Threshold 0. Z is equal to W times input. Now these are two vectors. We need to multiply this by this. First input by the first weight, second input by the second weight, third input by third weight, fourth input by the fourth weight. So we need to do a vector multiplication. So it is correct to use the dot. However, I prefer to have it the other way around. There's nothing wrong with your code. It's completely okay. I like to have it the other way around. So input first. And you do the summation because you want to add them. Okay, fine. And I think you have something a little bit fishy about here. Now, if you look at the PowerPoint, you have these inputs and weights. You might multiply them and get the net value, and that net value is compared to the threshold. If the summation value is larger than threshold, output is 1. If the summation value is smaller than threshold, the output is 0. So you need to compare the summation value. So the summation you get here is the net. So it's the net that should be compared to the threshold. And depending on that, your output should be either 1 or 0. Okay? So Lakman, you have a small correction to do. Other than that, I think your code is okay. And Tushar has posted another code. Let's say, you have changed the threshold to 0. Okay, that's for the time being. But in the next example, don't change it. There will be a time for you to change it, but the next example, you might not be work if you put it to 0. Clear CLC input. Okay. Tushar, in your code, you may need to check a little bit about your for loop. Right? You need to check what you're doing in the for loop because you only need to compare a single value. Although you have multiple values at the beginning, you multiply each input by its respective weight and then add together. You add all those things together to get a single net value. Right? So there won't be you won't be needing a for loop. And Janet, I think again you would have to check what you're doing. You have the inputs as A, W as weights, M, you're probably thinking about the weights. And Janet, I think again your one is the same case.
I checked that and my output is coming. It says 0.5.
Sorry,
Output
that's the vehicle going. I couldn't hear you. Can you tell me?
I run this program on Octave.
Okay.
the summation is Z is come as 0.5 and neural output equals to 1.
Which code are you referring? Now I am referring to codes. One is by the Janath and one is by the.
I'm Janath here.
Okay.
Yeah.
Right.
I did this first I your
Right.
multiply.
I got some of the idea. Okay. So the first thing is so there might be some issues. Okay. Let's see. So the first part of your code is okay. So the only thing I am worried about is up to this point it's okay. So A.W means you are multiplying your A or the inputs by the weights.
Yeah, element wise multiply.
This one got an error. One then this was okay. That n not be here. Right. We have another implicit. I think you are using not the MATLAB syntax anyway. So what happened here is you have the M, which is input multiplied by the weight. So your result would be a set of values.
Yeah.
So you need to place to add them together to get the net value.
Yes, it's done in the for loop.
It's done. You did it in the for loop.
Yeah.
Right. Okay, then yeah, then your code is correct, but you could still use a some word keyword for some to add them.
Sorry, I can't hear you.
Your code is okay.
Yeah.
But you could use a shortcut.
Yeah. I have to use some command.
Yeah, you can completely remove all these lines and simply say some a dot.
Yes.
And then yeah, your code is okay. Only thing is this one is a little bit lengthy because of that for loop. Other than that, it's okay.
Okay, sir.
And Lakman, what happened to you? Lakman, I think your one is okay. Yes, you have corrected it. Right. Now you know how to write a code to run a small single neuron. So if the input values or weights or threshold change, the output will change. Right. So this is basically all you need to know about the neural network programming. Other things are simply extension of these things. Right? Okay. We'll gradually add few more components to this particular code. But this would be the base. So if anyone still having problems, please let me know quickly. Because once you start point after this point, I will assume you know how to write this small code, this part of the code. Okay. Right. Now this thing seems a little odd. So what we had done is we had put some inputs and we had put some weights and some calculations and get some output. So how can it solve complicated problems that we have been talking so far? At the beginning, I said that these neural networks are able to handle a lot of problems similar to humans, things where you have partial data and things like that. But this one doesn't seem to do much. Actually, it doesn't. So what a neural network does is it's quite different to conventional programming. In a conventional program, it's the programmer's knowledge and wisdom that get translated into the program. So if you had something like a calculation program or a website or maybe online booking system, you have an expert that explain the business logic to the program. The business logic might say, okay, if the customer comes and pays this amount, put it into this account and put this amount of discount like that. Then the programmer go through that and instruct precisely what to do in each case. So in a conventional or the hard computing program, everything the computer does is predefined by the programmer. So the programmer is the main person, programmer or the software team or somewhere. They decide how it functions, and the computer simply follow all the instructions. But for a case like a neural network, it's completely different. For example, let's say you want to identify the signature, whether this is the correct signature. It's very hard to write a program for this. How are you going to identify signatures? Are you going to measure the length and size of every signature? Because from in the same person, the signature can slightly vary. Or let's say you want to identify cats in the image. So how are you going to identify a cat? You can say it's some animal with a round face, with pointed ears and flicks and things like that. But again, how are you going to program them? How are you going to say a rounded face? First, you have to know what the face is. And are only the cats having round faces? So there are so many things. So the problems the neural network tackles cannot be programmed into a software. Okay? So the data and the complexity makes it impossible to program all the information into a neural network. So what we do is, we create a basic neural network using the neurons, the ones that we have just completed, similar to those ones. And then we do something called training. So training means we show the neural network some examples. We can show him some examples of the cats and say, okay, these pictures are the pictures of cats. And then we can show it some images that doesn't have cats and tell these images doesn't have cats. Now learn from those images. So it's sort of like that. You don't actually program the neural network, you just create it. So the code we had wrote is only to create the neuron. The actual training happens in the weights and the threshold values. So those we let it automatically handle. So when we are saying we are programming neural network, we are basically creating a structure, and after that we have to train it by showing it some of the examples. Okay? So it's just like when you are training, let's say, a dog or something, right? So you can't instruct a dog like when you are doing a program, right? You can't write a script and say, okay, jump 3 times, roll once, and play it in the next time. Dog will not understand. What you need to do is you have to train it. If it does a good thing, let's say it jumps 3 times, you can feed it, pat it on the back, and if it does something bad, he just run all around you. Then you can scold him or hit him or do something. So it gradually learns which are the correct answers and which are the wrong reactions. Neural networks are similar. You have a neural network, you give a particular input and check its output. If the output is what you need, then you let it have it. If the output is different, you train it, you punish it. Although we say punish it, what you're basically doing is you are adjusting the weight until the error is reduced. Right? So the training is basically adjusting of the weights. So depending on the weights, your output can change. Even for the same input, if you have different weights, you will get a different output. Right? So the process of training means adjusting weights in such a way that the error becomes less and less. So this adjusting is done by different algorithms. Some are complicated, some are very easy. Right? So that's all there is to neural networks. You have a set of neurons that have weights and connections. You show it some examples and ask it to adjust the weights so the error is reduced. You do it multiple times, 1,000 times or 10,000 times until the error is in a reasonable level. So there are 2 types of training. One is the supervised training. In the supervised training, we know the correct answer. Right? So we show the examples that we show to the neural network, we already know the correct answer. So we can force it to adjust to that correct answer. But in certain cases, even we do not know the correct answer. Right? There are some questions that even humans don't know the correct answer, but we like neural network to do it. So those kind of cases we call as unsupervised training. Right? So we will not discuss the unsupervised training. We will be focusing on the supervised training. So we'll try to do a supervised training on a very simplified example, right? It's a very simplified example, maybe overly simplified. The reason I said overly simplified is this one lacks some of the key features that needs to be in the neuron. But for the time being, we'll assume this is the neuron because it will make it much easy for you to understand the process. And you may also note that this example can be easily solved using a conventional programming. So the rule of thumb is, if a problem can be solved using conventional programming, don't apply soft computing into it. Soft computing is a last minute resource. If there's nothing works, then you do the neural networks or soft computing or genetic algorithm or something. But if you can get away with the for loop and if condition, do it. Okay? For the example I am doing, you can easily do a conventional programming and get the correct result. So the only reason I'm giving it to you at the moment is to show how the neural network functions. For in the real world, don't use neural network for this kind of simple problems. Okay? So what is this simple problem? Assume you have a single neuron. It has only a single input. And usually a neuron has multiple inputs, and you usually have a special input known as a bias. But for this example, we will ignore bias and we will have only a single input. And our transfer function is a hard limit at 5. That means if a net value is larger than 5, output becomes 1, otherwise output becomes 0. And this network has only a single neuron. So although you call network, it's a single neuron. Right? So that's as simple as you can get. Single neuron, single input, and nothing else, and transfer function is hard limit. So what can this single neuron do? Right? Right. So we are going to use the single neuron to check whether a student has passed the exam or failed the exam. Now, of course, if you know the cutoff mark, you can very easily write this program. You can simply use a single if condition and write a program to check whether the student has passed or failed. But that's not the approach we are going to use. We want to use a neural network. We are going to use a single neuron. So we are not going to write a if condition to check whether it's passed or failed. Instead, we will create a single neuron and show it some examples. We will show the example of these 1, 2, 3, 4, 5, 6, 7, these 8 students. So this is a sample taken from the class. So the marks and the grades are provided. So we'll show it this to the neuron and ask it to learn. So once it had learned this particular one, we will give the marks of another student that is not in this sample and ask it to classify whether the student has passed or failed. Okay, did you get the idea what we are going to do? Okay, did you get the common idea of what the problem is about? Then we can start writing, but first you need to understand the question. Question is, you need to know whether a student is passed or failed if the marks is provided. Now we have a sample of the grades student had got. We will train a neuron to do the same, do that thing. Whenever the marks is provided, it will say whether the student is passed or failed. Are you okay with the question? Are you familiar with it? I need some feedback. Okay.
So, sir, how we choose the weight in this database?
initially you can randomly choose them, but after that, if you remember, I said adjusting weights is the training process, and there are different algorithms available to adjust the weights. So once you finish this one, we will learn one of these algorithms. So that algorithm can automatically adjust the weights in our neuron. But for the time being, we will just put some random numbers for our neuron, okay? Right. So let's start coding. So it's a single neuron. What happened? Okay, it's a single neuron. So we'll start with creating a new script file. For the input, I have a variable called trin. And for the weights, let's add some random weights. Or maybe you can put some number. Let's say the weight is 0.5, just for the fun. So the training input, for the time being, let's say 50 marks. So these are the marks. This is the weight. And the threshold is said to be 5. Okay. Can you write a code for a single neuron to get the output for this single mark? Okay. Now don't worry about whether the answer it gives is correct. That means whether it's correctly classifying as pass or fail. Don't worry about that. And don't worry about the rest of the students which has different marks. Just consider on this particular student that's having 70 marks. So let's say you created this neuron and the input is 70, which is the mark, and it will output some kind of result, either 0 or 1. By the way, I forgot to mention, when you're doing the neural networks, everything has to be in numbers. But here, if you look carefully, you will notice there's something called fail or pass. Now we have to encode it to a number, otherwise neural network will not work. So we can say fail is 0 and pass is 1. So if you give, whenever you have 0 as the output, that means the student has failed. And if you have 1 as the output, that means student has passed. So we need to change our training. When you are doing the training, we need to change these grades to 0s and 1s. And when the neural network outputs 0 or 1, again we need to convert it back so the people can understand. Okay, can you quickly create a neuron for this one? So it should be very similar to the one that you have done earlier. Only things now you have only a single input, not multiple input. Single input on a single weight. And threshold is changed from 0.5 to 5.
So,
Yes, okay. We'll finish this particular example and see what we can do. Yes, there's a question, I think.
if the output is, net value is greater than or equal 5, what should be the output? Is
It
it
should be 1.
1?
If net value is larger than or equal to threshold, it should be 1. If it's smaller, it would be 0. I think next session start at 3:30. I think I have about 8 minutes if my clock is correct. Okay, someone has input 70. Threshold, okay, good. By the way, from this point onward, rather than using the display, simply assign the value to the network output. So it will automatically display also. But in addition, you can use it in the following neurons. So you can display the output, and also you can mesh the output to something called ANN out. The output should be ANN out. That's the variable, the one you see here. So you can say ANN out is either 1 or 0 based on that. TRN is 7%. Okay, there's another code from Lakmal. Okay, let's see whether that works. Okay, it gives a result, but it's better if you can change it to net in and out. Assign 1. Because in neural networks, we always use the numbers. So you get either 1 or 0. What about there's another student done over 70.5 threshold. Okay, your code is okay. Again, the same thing. You can improve it by removing the display and saying it as in and out. And in addition, you will. I'm not sure why you are using M and then adding a net to the 0. You can do it with a single line if you want. But that's not an error. If you want, you can improve it like that. Okay. So I think everyone gets the idea how this particular code works. Unfortunately, for the time being, it doesn't give you the correct answer. For the 70, it says pass marks. But if I put something like 20, again, it says pass. So the network is not trained. So in the following day, the next day, we will learn how to properly train the network. We will write a small code to adjust this way, so it will learn and pass only the correct group of students. Okay. So let me very quickly recap what you have learned so far. You learn why neural networks are important, and you learn there are different structures of neural networks and applications. And you learn it's a way of using simple processes connected to process the complex data. And we are using the feedforward network structure, which has multiple layers, and you have connection between the layers, but no connection inside the layer. And a single neuron consists of inputs, multiple inputs, and weights attached to input and a single output. Inside the neuron, you will multiply input by its respective weight and add them together. After that, you will compare. After that, you will send it to the transfer function. If the transfer function is at hard limit, it will compare with the threshold value and see if it is larger or less than the threshold value. So that will be your output. And then we wrote a small program to do that in the MATLAB. And we also learned, we train the neural network, do not write the neural network core. So training means we adjust the weights until the error is reduced. So today we don't have time to do that weight adjustment, but in the next day we will learn how to do that weight adjustment and come up with the program. If you're interested, you can use the PowerPoint. I think it has some steps in the upcoming session. Otherwise, we will cover it on the next day. Do you have any questions regarding today's session? And by the way, if possible, try to install MATLAB 2013 or later version. So we will be all be doing the same software. It will be easier. Will it be possible for the people who don't have it to find it by next week? By next Sunday, will you be able to find MATLAB? Yes, no? Okay, please try to find the MATLAB as well. Then with that, I will wind up this session and check the LMS. Maybe there could be some updates for the learning material as well. Okay, and good afternoon and have a nice day. Okay, bye.